Not every journey is easy. Not every road takes you straight to success. Not every decision is the smartest. But without man's curiosity to experiment with life and its surroundings, advances in technology and space exploration would never have taken flight. For over 50 years, space exploration has risen to become one of man's most notable accomplishments. It's interesting how two countries obsessed with destroying each other with bombs sparked a new generation of space exploration. Without the unfortunate events of World War II or the Cold War, NASA would not be able to stretch its arms into space the way they can today. All of the guns, rockets, and war ultimately led to the questioning of humankind's existence in outer space. Although humans have survived for thousands of years on the Earth's surface, they cannot yet do the same while orbiting in space. Even when exposed to very dangerous elements, astronauts still challenge themselves with space exploration for the sake of science. Between engineers, scientists, and programmers lies a deeper reason, a deeper uncertainty that leads us to believe life exists beyond our own world. In 2003 kicked off with an intense investigation of life beyond our planet. With intentions of discovering water on Mars, NASA began selecting scientists for their newest endeavor, the Rover Explorer mission. NASA's Rover mission was created in hopes of exploring the surface of Mars. Like the Moon, Mars can get extremely cold and does not have much of an atmosphere. Compared to the Earth, Mars has only 1/3 of the gravity and is layered with fine dust called regolith. With an incredible amount of experience and information, NASA constructed 2 rovers to explore the surface of Mars in hopes of finding evidence that water once existed on the planet. On June 10th and July 7th, the Rover Explorer mission successfully launched the 2 rovers to Mars. With names like Spirit and Opportunity, NASA was sure their rovers would operate properly.
Main engine start. 1, 0, and liftoff of the Delta rocket with Mars Pathfinder.
Encased in a strong airbag-protected craft, the rovers landed on Mars about 7 months later. Spirit and Opportunity began collecting and returning data to Earth, where the Jet Propulsion Lab had 28 scientists monitoring the activities. Both Spirit and Opportunity carried cameras to focus on surrounding territory, thermal spectrometers for testing temperatures, magnets to collect dust, and many other tools that aided in discovering new material on Mars. Cameras were stabilized at least 5 feet above the rover and showed a full circular panoramic view. The thermal emission spectrometer both rovers carried was used to pinpoint how rocks on Mars formed. Scientists back on Earth also monitored the spectrometer to record the atmospheric conditions of the planet. Another cool gadget installed was a rock abrasion tool that removed old and weathered surfaces to expose new layers. In turn, this allowed for a deeper experiment with the surface of Mars. As the scientists collected data sent to Earth, the Spirit and Opportunity continued to explore the planet at a pace of 1 mile a day. Although Spirit and Opportunity were only expected to survive 90 Martian days, scientists were astonished when they continued their research 300 Martian days later. While photos continued pouring in from the rovers and new information about the terrain continued to grow, scientists on Earth began piecing together the mystery of Mars. Examining rocks and surrounding atmosphere concluded that, yes, water had once existed on Mars. All of the efforts and success from NASA's rover mission had stimulated future plans to explore the rest of our neighboring planets. As the Mars rovers continue their exploration, NASA has dawned a belief that soon people can colonize the planet. NASA hasn't always been organized and successful. Years of turmoil have tarnished its pristine image, but without the hardships, NASA wouldn't be as experienced as it is now. Before NASA, the U.S. grew desperate to launch a satellite into space. Talk began for a series of projects that could deliver that dream, but as history has shown us, not everyone has the same dream. A major problem the U.S. fumbled across was finding one single organization to build and design a satellite. With hundreds of scientists from World War II, the U.S. struggled to narrow down who would pursue the final plans for a sufficient rocket or satellite. With at least 4 rockets in development, the U.S. had many options to choose from. As soon as the Navy, Army, and Air Force began their own development, problems quickly arose. With knowledge that whichever service successfully completed their project first would ultimately become the dominant power, the Army, Navy, and Air Force thickened the rivalry. Originating as an agreement in 1955 between the Army, Navy, and Air Force, the satellite project focused on producing an ICBM with a range of over 5,000 miles. With the help of German scientist Wernher von Braun, the Army began with the orbiter, which would serve as a booster named Redstone. Beginning with the development of a minimum launch vehicle, the Army and Navy worked almost as one, creating boosters and satellites to analyze data. The Navy focused more on Vanguard, which was based on a research rocket. The launcher that Army prepared consisted of 3 stages. The first would be a booster named Redstone, the second a series of small aircraft rockets, and the third would be another cluster of rockets used to propel the satellite. With all these separate projects flourishing, Eisenhower decided to choose the best project for the U.S.
He was not a space cadet. He used to say, as he looked over his shoulder, and he'd say, you know, Keith, that moon's been there a long time. It's going to be there a great many eons yet, and we'll get there one day, but it isn't necessary we break our necks and break the budget to get there now.
Deciding on Vanguard as the central project, Eisenhower hoped it would reduce the goods, but without the right tools, money, and designers, Project Vanguard quickly diminished. Von Braun wasn't discouraged by the Army's setback. He was not chosen by Eisenhower, but he trudged on, fine-tuning his rocket development skills in Huntsville, Alabama. With his rocket booster Redstone, von Braun tested and retested its ability to survive re-entry into Earth. With his knowledge, von Braun created a booster with several stages, allowing for smoother re-entry into Earth. He called this new model project Jupiter-C. Even though the Army and von Braun were experiencing success, their projects were limited to just experiments until Vanguard was finished. But decisions began shifting when the Soviet Union successfully launched Sputnik 1 into orbit. As funds diminished, the Navy leaned on the Air Force for help, requesting satellite tracking facilities. As all 3 groups squabbled over control, destructive rumors spread about the Navy's Vanguard development and the Army's orbiter design. Although not for long, tensions settled after the Vanguard project fully went underway. With little attention being poured into the Navy's efforts, it became clear that the weapons program was a top priority. As ICBM development flourished, Vanguard's stability fell apart, being labeled as a project that would crumble at launch. With so much disdain for the Vanguard project, the Pentagon offices quickly reduced funds, shrinking Vanguard's capability. With this in mind, the Army went full throttle. As von Braun finished the orbiter, Eisenhower took notice, labeling it an acceptable project to launch. With much anticipation, von Braun waited for his historic moment. On January 31st, 1958, von Braun's Jupiter-C was successfully launched with the Explorer 1 satellite. In space, Explorer 1 set out to measure and explore atoms. While orbiting, the satellite stumbled upon some amazing things. Head scientist James Van Allen noticed the Explorer 1 failing to continue its measurement and discovered a thick belt of dense atoms that could not be processed. This belt was soon labeled the Van Allen Belt. With so many discoveries, the Armory and von Braun knew they had taken place in history. Eventually, the Vanguard project flourished and launched a satellite on March 17, 1958. Dwarfed by the Soviet success, this tiny step forward didn't do much for the U.S. With the launch of Soviet Sputnik 3 a couple of months later, Vanguard seemed insignificant. Though the Vanguard failure enhanced confusion and shortly deterred space exploration, the U.S. was able to continue their dream with the launch of Explorer 1. As the sophomore orbiter in NASA's fleet, the Challenger had a reputation to uphold. Using solid rocket boosters for the first time, Challenger remained an all-or-nothing mission. All of the orbiter shuttles in NASA's fleet are extremely expensive due to their complex parts. The upkeep on the orbiter, external tank engines, and boosters alone sent NASA's budget into the billions. Storing all of the shuttle's parts becomes expensive because of their size. The external tank alone costs millions, and it is disposed of after use. Still knowing the project would cost millions, NASA went ahead with the mission. With goals of positioning the Tracking Data Relay Satellite 2 and installing tools to observe Halley's Comet, scientists prepared for a 6-day journey through space. Completing 9 previous flights and flying almost 26 million miles in space, the Challenger STS-51L set up for its 10th mission in January of 1986. The temperature before launch was frigid and almost prevented the mission from ever occurring. Ice began to develop on the framework and threatened the main pipes of the shuttle, but crews assured the astronauts it would melt before the final launch began. The next morning, anxiety flourished when crew members discovered ice still chilling on the framework. The original launch was delayed by 2 hours, and the temperature remained 15 degrees colder than that of any previous launch. The Challenger STS-51L eventually launched on Pad 39B at 11:38 a.m. on January 28th at the Kennedy Space Center, which is located at 28 degrees latitude.
6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Control program. Roger, roll, Challenger. Good, roll program confirmed. Challenger now heading
Previous
down
flights
range.
ran smoothly, but for flight STS-51L, problems began within seconds of takeoff, when unusual puffs of gray smoke splurged from the right solid
Engines
rocket
beginning
booster.
throttling down now at 94%. Normal throttles for most of the flight, 104%.
Seconds dashed by as a black smoke surrounded the base of the shuttle, alarming the space station of lurking problems.
Throttle down to 65.
As the Challenger continued its launch through intense wind conditions, burning debris caused severe pressure differences in both boosters, sparking a small fire. Crew members on Earth were getting nervous, but astronauts on board were unaware of the dangerous situation brewing. After 64 seconds, flames circled the shuttle's external tank, escalating for 10 seconds while a white vapor engulfed the shuttle.
Find out trajectory. Go ahead. Flight GC, we've had negative contact, lost downlink. Okay, all operators, watch your data carefully.
Flight final till we get stuff back. He's on his cue card for abort modes.
Flight GC, negative downlink.
Copy.
Unfortunately, the astronauts couldn't prevent the new few seconds from occurring. At an altitude of 46,000 feet, the Challenger's hydrogen tank exploded, killing all 7 astronauts
Copy.
on board.
Fido, can we get any reports from recovery forces?
Stand by.
Fido flight.
Go ahead.
Did the RSOs have an impact point?
Stand by.
Crew members on Earth were shocked and glared at the shuttle falling apart in the sky. Nothing could have been done to save the astronauts on board, and because of the inability to escape an emergency, NASA knew that they had to make some changes. Although some believe the astronauts were able to grab their air packs designed for emergencies, not a single astronaut was able to survive the disaster. All across America, people mourned the death of Challenger's astronauts, setting up candlelight vigils and holding mass prayers. The disaster took the lives of mothers, fathers, and teachers. Among the crew members was Christa McAuliffe, who was attempting to become the first teacher in space. NASA was disappointed with the shuttle failure and had to start from scratch with preparations for the next mission. Hundreds of experiments planned had to be scratched and rescheduled for other flights.
You got it? I have no idea, man.
A Challenger was expected to set up Spartan, a satellite to collect data on surrounding comets. On its first day, the shuttle is to begin checking satellites and preparing for deployment of new machinery. On the second day, Christa McAuliffe was scheduled to start the Teacher in Space, or TISP, videotaping. She planned to deploy Spartan for all to see. Unfortunately, no experiments were done and no satellites were deployed. The devastating failure of Challenger triggered shuttle launches to cease for 32 months. NASA mourned for the loss of their astronauts and quickly investigated the shuttle's demise. Recordings of the last few moments on Shuttle Challenger have been transcribed, and the last remark heard was pilot Michael Smith murmuring, "Uh-oh."
We have a video release of the way in which the fragments from the STS-51L accident are being brought back and after being cleaned up are being laid out on a grid in the KSC logistics facility. You'll notice that they're being placed on a grid drawn on the floor in conformance with the National Transportation Safety Board's normal procedures. The view shown on the videotape is taken looking from a corner of the facility along the port side or the left side of the orbiter from the tail looking forward toward the nose.
A week after the disaster, Ronald Reagan gave his State of the Union speech. To this day, his speech has remained a collection of some of the most heartfelt words.
We come together today to mourn the loss of 7 brave Americans, to share the grief that we all feel, and perhaps in that sharing to find the strength to bear our sorrow and the courage to look for the seeds of hope. Our nation's loss is first a profound personal loss to the family and the friends and the loved ones of our shuttle astronauts. The best we can do is remember our 7 astronauts, our Challenger 7. Remember them as they lived, bringing life and love and joy to those who knew them and pride to a nation. They came from all parts of this great country, from South Carolina to Washington State, Ohio to Mohawk, New York, Hawaii to North Carolina, to Concord, New Hampshire. They were so different, yet in their mission, their quest, they held so much in common. The future is not free. The story of all human progress is one of a struggle against all odds. We learned again that this America, which Abraham Lincoln called the last best hope of man on earth, was built on heroism and noble sacrifice. It was built by men and women like our 7-star Voyagers, who answered a call beyond duty, who gave more than was expected or required, and who gave it little thought of worldly reward. Today, the frontier is space and the boundaries of human knowledge. Sometimes when we reach for the stars, we fall short, but we must pick ourselves up again and press on, despite the pain. Our nation is indeed fortunate that we can still draw on immense reservoirs of courage, character, and fortitude, that we're still blessed with heroes like those of the Space Shuttle Challenger. Dick, Mike, Judy, Elle, Ron, Greg, and Krista. Your families and your country mourn your passing. We bid you goodbye. We will never forget you. May God bless you all and give you comfort in this difficult time.
Although Challenger set a somber mood for following missions, it still exemplified NASA's drive to continue and achieve greater things.
And one of the things we get to do that's very enjoyable is look out the window. Here's a beautiful view of the Earth as we come and make landfall over the continent of Africa in the vicinity of Morocco.
Space shuttles were intended to begin serious launching in the early 80s, but with major delays, NASA postponed any launches. Shuttle Columbia was developed in the 80s, but launches were constantly being delayed. During regular checks of the first Columbia, a computer failed, leaving the crew with questions of safety. This bump in the road proved many people and many hours are needed to efficiently maintain a shuttle and its components. With crews frantically searching for answers, NASA ordered up over 100 computer experts to come in and repair the situation. Millions were poured into this mission, but NASA knew the reward for patience would be sweet. Columbia, the oldest orbiter in NASA's fleet, was constructed in 1975 at a California base right before transferring to John F. Kennedy Space Center on March 25, 1979. Scientists began fine-tuning the shuttle, preparing for its experiments in space. In 1983, NASA began planning Columbia's mission. Years of successful launches proved Columbia's stability as a shuttle and its ability to launch like a rocket and land like a plane. On its 28th mission, Columbia STS-107 focused on gravity and solar activity while also exploring new ideas about space. NASA began the astronaut selection process, choosing 6 astronauts that previously served in the Air Force or Navy and 1 aerospace engineer. Of the 6 astronauts chosen, Columbia STS-107 carried the first non-American man attempting to orbit in space. Although the intended launch date for Columbia was January 11, 2001, the shuttle got delayed almost 2 years because of cracks in the propellant system. The next year was spent repairing the shuttle to perfection. Finally, in January 2003, Shuttle Columbia was ready to launch. Mission managers assured the 6 astronauts that weather conditions were stable for Thursday, January 13th, and all other problems had been smoothed out. The space station began preparing for Columbia's launch months in advance, but the real excitement began early Thursday morning. The crew of Shuttle Columbia waited anxiously on Pad 39A at Kennedy Space Center, listening for their mission to begin. The air was electric, and the Space Center staff finished off any problems the shuttle previously had. As the astronauts said their last prayers and finished any preparation work, countdown began. At exactly 10:39 a.m., Shuttle Columbia embarked on a 16-day journey into space.
See the roll program here as the sun kind of shines through the cockpit. Right there, the orbiter is going through its roll maneuver, roll program, and the vehicle just flew beautifully. We had a a great ride. We had brilliant sunshine coming in through the windows in the front, and it was just a fantastic ride all the way up.
From the naked eye, the launch ran smoothly. But later that night, special cameras caught a glimpse of disaster waiting to happen. During liftoff, a piece of insulation foam hit the shuttle's left wing, but there were no major concerns with unbearable damage. With all critical systems intact, crew members aboard Columbia relaxed, settling in and preparing for the days to come. Life aboard the shuttle was anything but normal. Even food was drastically changed. While in space, the crew ate about 1 to 2 kilograms of food each day. Previous shuttle missions were shorter in length and did not focus on food supply as much as present missions. Members of Columbia ate some powdered food and some throwaway food, but because of the mission's length, recycling was a big part of daily life. Some food was packaged in plastic and left for the astronauts to heat or chill at severe temperatures. Water was also contained in plastic cases and supplied readily.
Our undying appreciation goes to the folks who pack and manifest all the food for us so that we have these great meals up here. CKC, how the tray is arranged and how you can see things are really packed in there, but you can see some really good stuff like cookies, and here KC's pulling out one of the breakfast items, granola with blueberries. Here KC is preparing breakfast at our galley. We have what is called a rehydration station. That's just a fancy way of saying that you're going to put some water into this dried food and get the moisture back into it again. We've got these vacuum-packed plastic bags that the food is sealed in. This looks like she's got some granola with blueberries here that she's preparing for breakfast. Once we let the water soak back into the food for 5 to 10 minutes, then you can cut the package open with a pair of scissors and then eat it with a spoon usually.
Sleeping on bunk beds, the crew members split into 2 groups, blue shift and red shift. This enabled one group to sleep while the other worked. At 11 p.m. Thursday night, the Blue Shift began their operations. Arranging the Space Hub module and restoring computers on the shuttle, the Blue Shift worked for the next 12 hours. As days passed and the Red Shift swapped with the Blue, hundreds of experiments were followed out. Because space travel is mostly based on computers, equipment aboard Columbia remaining intact was essential. Hundreds of computer experts and scientists were assigned to constantly monitor the computers, even when they were not in use. If one computer failed, the whole shuttle would be thrown out of whack. While in space, the Columbia orbiter floated quietly, setting up communication devices and collecting data. The crew worked hard on experiments, routinely sending the results back to Earth.
You can see Rick's husband here in Space Tab, the double research module. He's working on activating the water loop. He has removed one of the panel covers in the aft module. You can see the very impressive plumbing underneath this lab floor, while above the floor we seem to be working in peace with all these experiments. Underneath, a lot is happening in terms of systems.
This is KC, and she's working on an experiment known as BioPact, which is from the European Space Agency.
One key experiment that defined Columbia in history was softball. With hundreds of experiments behind them, the Blue Shift crew aboard NASA's Columbia STS-107 concentrated on the softball experiment. Softball, standing for structures of flame balls at low Lewis number, explored flame activity at low gravity. On Shuttle Columbia, the crew was interested in the improvement of fuel. Using results from previous tests, crew members discovered new ways to reduce emissions of gases while increasing energy efficiency.
There's Mike Anderson conducting a combustion chamber experiment, which is called softball. And we're looking at Mike here, ignites 3 ball flames ball, and here is a close look of the balls of flames in space in our monitor.
These experiments showed different levels of combustion that are not visible on Earth, giving birth to the study of fireballs. These stable spheres of fire present themselves when combustible gases with low Lewis numbers are mixed. Studying these fireballs allows scientists to monitor 2 necessary stages of combustion: chemical reaction and heat mass transport. On board Challenger STS-107, crew members filled a 26-liter cavity with a diluted mixture of hydrogen, oxygen, and 1 motionless gas. Once full, a spark was ignited and heat poured from the fireballs. The crew's ability to measure the flame for almost 500 seconds spurred a slew of world records. Some softball highlights include the weakest flame ever burned in space or on ground, the longest-lived gas flame burning for an entire 500 seconds, the first premixed gas combustion project performed in space. The intense development of low fuel inspired future scientists to continue the study, and the first demonstration of reabsorption of radiation based on a flame's burning properties. All of the remarkable findings in Project Softball illustrated how gravity affects flame. The Columbia crew worked hard day in and day out, trying to test hypotheses and create new theories, but as time in orbit grew slim, feelings of sadness emerged. On February 1, 2003, the flight control team began preparations for Columbia's re-entry. There were no problems or concerns with the shuttle, nor did the flight control team see any direct damage from debris that fell during takeoff. As the astronauts routinely steered the shuttle towards Earth, signs of distress began popping up. At 8:48 a.m., the left wing strained, but the problem was not initially shown as a threat to the shuttle crew. As Columbia soared over California, debris began shedding through the sky. To those grounded on Earth, the shuttle looked like a streak of light. Continuing over Utah, Arizona, and Texas, the shuttle began to feel problems. Astronauts on board were puzzled by the surprise malfunctions and tried to get help from the crew back on Earth. At 8:59, the shuttle lost all communication and unexpectedly exploded in the sky. Those watching the shuttle heard an incredible boom and saw the shuttle falling apart in midair. The flight control team grew confused and could not believe their astronauts and shuttle were burning in the sky. As the wreckage fell, hearts across America broke. NASA officials immediately called for crews to begin hunting the area for any wreckage or clues. As emergency centers searched the waters, Americans remained stunned at the disaster. Days crept by, and little by little the shuttle was found. Pieces scattered far apart were brought together to be rebuilt. Stored in a warehouse, the pieces recovered from the shuttle were placed on a grid so crews could slowly and carefully come to some kind of conclusion as to why Columbia fell apart in re-entry. While the country wept, President Bush somberly addressed the United States and promised America that the space program will continue on. Trying not to jump the gun, NASA officials began speculating on the cause. NASA Space Shuttle Program Manager Ron Ditmore said that the first indication was loss of temperature sensors and hydraulic systems on the left wing. Seconds turned into minutes, and Columbia faded fast. The disaster has left a deep imprint on NASA's history, but set the stage for a new development in shuttles. Back in the 50s, when the Cold War was still in gear, tension rose when nearly 5 days after Soviets launched Sputnik, President Eisenhower granted the Army an okay to begin intense space research.
On October 4th, 1957, as I recall it, the Russians launched a fairly heavy object into orbit, and that caught us really by surprise.
With intentions of surpassing Soviet accomplishments, the Army Ballistic Missile Agency jumped on Eisenhower's permission and successfully tested missiles. With a very ambitious plan, the ABMA continued development of powerful boosters which they felt would orbit crew with supplies, provide scientific research, intercept enemy satellites, and successfully send a man to the moon. Envisioning a two-man crew, ABMA soldiers drew up several design proposals. As the reality of space crept closer and closer, von Braun, head of the Army's project, assumed he would gain control of all rocket and satellite progression.
The Vanguard project had gotten underway in 1955, as I recall it, part of the IGY program, International Geophysical Year program, but it wasn't anywhere near ready. They had, I think, scheduled some launches late that year, that is in 1958, but it wasn't clear that they were going to be able to fly them. There was another competitor which had really never been recognized, and that was the Army with their Jupiter, which together with some upper stage solid rockets developed by the Jet Propulsion Laboratory in California, finally was the vehicle which launched a satellite for the U.S. early in 1959.
To von Braun's disbelief, someone else had control of all satellite development and decided to leave satellites in the hands of the Jet Propulsion Lab, not knowing the Jet Propulsion Lab would soon create America's first spacecraft, space exploration, in the hands of man. As the project tanked on, leaders of the Jet Propulsion Lab realized the importance of space exploration over weapons development. With new plans, the JPL began developing Explorer 1, a satellite that would contain its own rocket. With two sections, the satellite would contain 2 radio transmitters and 3 measuring instruments that would record information as the Explorer orbited. Finally, when Explorer 1 was suited to survive space, the Air Force prepared for an incredible launch. With the Navy still pressuring to launch Vanguard, pace quickened, and Explorer 1 was launched at 10:48 p.m. on January 31st. With a bumpy launch, it took scientists over an hour to pinpoint Explorer's orbit. The success of Explorer 1 launched a new era for space exploration. Responding to the successful orbit of the Soviets' Vostok 1, the U.S. generated the Mercury project. Developed in 1958 as a 4.5-year program, it became the United States' first test to send a manned spacecraft around Earth. Ultimately completing 6 manned flights between 1961 and 1963, the Mercury project illustrated man's ability to function as both a pilot and an experimenter. Using chimpanzees in their initial test flights, the project began exploring the effects of zero gravity and remained intent on safely launching a man into space. In January of 1961, the project sent a chimpanzee named Ham into space. Trying to test the capsule's ability, the chimpanzee went through several tasks before returning back to Earth. With the success of the launch, NASA gave the go-ahead to start attempting a manned mission. Alan Shepard was chosen to man the mission's first attempt. With a set date of March 1961, German engineer von Braun worked ruthlessly through tests and eventually rescheduled the flight to May due to booster modifications. In between those two dates, the U.S. received news that would damage their egos. On April 12, 1961, Soviet engineers had successfully launched Yuri Gagarin into space, stealing the title of First Man in Space. Although the Soviets had already reached space first, the United States still recruited over 2 million people and combined their skills to ensure the pilot's safety and bulk aerospace activity. Staff members worked night and day to create a spacecraft that could resist 3,000-degree heat and still function in space. With a 7 by 7 foot capsule, the Mercury project began preparation for its first manned flight. Doubtful thoughts echoed through the United States, but the crew of the Mercury project pressed on. After several test runs, Alan Shepard was ready to take his journey. Finally, on May 5, 1961, Alan Shepard ascended into the atmosphere for 15 minutes in a cone-shaped capsule, becoming the first American man in space. After his success, the Mercury project continued with 5 more manned flights, adding new and exciting information each time. In the third manned mission on February 20, 1962, John Glenn became the first man to orbit the Earth. The project's last flight, manned by L. Gordon Cooper, remained in space for over 34 hours, orbiting the Earth about 22 times to record the effects of one day in space. Even though the Soviets were first to successfully launch a manned mission, U.S. engineers were able to take a big step forward towards the moon. As the Red Scare mustered fear in U.S. citizens and Soviet bombs threatened to drop, a new type of arms race began.
This nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Contrary to popular belief, the space race did not fashion itself among those solely interested in the moon and the atmosphere around it. The space race stemmed from the Cold War, when the Soviet Union and the United States toyed with using rockets for military demolition. Rockets first came into play during the 11th century when the Chinese used rockets shaped like arrows and armed them with a similar substance to gunpowder. With the introduction of gunpowder in Europe, scientists and military leaders began experimenting, creating dull and simple rockets. As rockets gained acceptance, German military gained control over research and development with leaders like von Braun and Dornberger. The German research explosion after World War II sparked new ideas in the Soviet minds. In 1944, the V-1 rocket was built. Powered by pulsing propulsion, this first cruise missile was reproduced over 14,000 times. As rocket development surged, Americans and Soviets saw its ability to revolutionize the planet. With the threat of Soviet ICBM rockets destroying millions of people in one shot, the United States began extensive research on rockets. Beginning with intermediate-range rockets, the U.S. set their sights high and eventually developed Atlas and Titan, 2 liquid ICBMs. As the race continued, U.S. forces used private contractors to help fund their research. After surrendering to the U.S. Army, German technical director Wernher von Braun entrusted his knowledge of rockets, initiating the next few years of development. In the 50s, U.S. research began producing 2 types of cruise missiles. The first was used during the Cold War as an interceptor missile, while the other was a terrain-seeking missile. The space race formally began in 1961, when U.S. President John F. Kennedy called for the landing of a man on the moon before the end of the decade. With fear of the United States, the Soviet government began building atomic bombs and devising plans to launch it in secret. In 1957, it was clear that the Soviets were making headway with their satellites, and U.S. officials grew frantic of being beaten in space exploration. Even though both the United States and Soviet Union agreed on a satellite's importance, it was the Soviets who capitalized on its value by launching Sputnik 1, the first satellite in space. Sputnik 1 totaled 82 kilograms and became a huge victory for the Soviets. Even after such success, the Soviets continued on to launch Sputnik 2 only a month after Sputnik 1. With a cone shape, this second endeavor launched a small dog into space. The U.S. had also attempted launching a satellite before the Soviets, but that effort was plagued with problems. The Soviets, feeling great about their triumph, began plans for a lunar program. The U.S. knew they had to work hard and fast to close the space exploration gap. While the U.S. discussed their progress in public, the Soviets kept their lunar missions silent and top secret. The Soviets' first attempt at a manned spaceflight began with Vostok, a new type spacecraft. In 1965, the Vostok was a two-part spacecraft with a section for the astronaut to sit and a section for the rocket booster. As time progressed and changes were made, the Soviets grew confident their design would be flawless. Finally, on April 12th, as the whole world watched, the Soviets launched Yuri Gagarin into orbit. Although Gagarin never committed to any experiments while in orbit, the launch was still a huge success. The U.S. was disappointed and needed to launch a manned mission very rapidly. With a country full of anxious citizens, the U.S. began their own testing of manned orbits with the Mercury project. Echoing the arms race, the space race jump-started many incredible journeys, sending humans into space and landing them safely on the moon. The competition between two rival countries actually birthed the era of space exploration. As the Cold War pressed on, military concerns from U.S. citizens pressured Congress to make a big change. President Eisenhower and James Killian from the Institute of Technology both agreed on the importance of science, but didn't want the future of space exploration resting in the public's hands. As a result, Eisenhower began the creation of a space team. Not knowing the National Advisory Council of Aeronautics had already existed since 1915, Eisenhower and Killian came up with NASA, an acronym for National Aeronautics Space Administration. The whole idea stemmed from Eisenhower's plan to orbit a satellite and gather information on Earth's atmosphere. Eisenhower's proposal to Congress established space exploration's purpose in American society. Officially created in July and launching on October 1, 1958, NASA began shaping a new face for space exploration. Lucky for NASA, German engineer Wernher von Braun and his crew were ecstatic to join the new program and begin work. NASA quickly started working on several projects like the Mercury project, which stuck to sending a man into orbit, and the Apollo program that focused solely on sending a man to the moon. Beginning with nearly 9,000 employees, NASA set out creating 3 essential research labs and 2 smaller testing labs. Langley Aeronautical Laboratory, Ames Aeronautical Laboratory, and Lewis Flight Propulsion Lab became the meccas of space exploration. Within months, NASA launched its satellite Explorer. With the capability to record radiation zones near and around the Earth, the satellite gave birth to the Van Allen radiation belt. As the years progressed, NASA began intense experiments testing human space travel. With the Explorer 1 in 1958, sending a man in orbit in 1961, the first man on the moon in 1969, and launching many successful shuttles, NASA has earned its great reputation. Continuing its mission to send man into outer space, NASA is always updating new theories and tests. During the 60s, space exploration was peaking, and the U.S. was growing anxious to win the space race. With a combination of NASA feeling extreme pressure to send a man to the moon, and support from John F. Kennedy in his dream to send a man to the moon, the Apollo program was born. Being compared to the sea, the moon was called the New Ocean. Just like the seas once attracted ships, space was now attracting shuttles. Established in 1963, the Apollo program aimed to develop man's capability to interact and carry out experiments on the moon. As the first real attempt to voyage far into space, the Apollo program began bridging the gap between man and moon. With so much riding on the mission and so many people working on it, the Apollo project was a huge risk. Even though Kennedy was unsure of the project's ability, he still mocked its slow pace. With more than half against spending $40 million in space exploration, the U.S. public was unsure of the project's potential. Although the $40 million could have been spent on medical research or education, NASA continued on with the development. The Space Sciences Board of the National Academy of Sciences commended NASA for its intrepid drive for space exploration and supported the overall cause of the Apollo project. With all of the scientists agreeing on the mission's creative aspect, NASA got the go-ahead to start the miraculous project. After taking years for the funding to come through, NASA started designing proposals and hiring staff to man the incredible difficulties of space exploration. Beginning with the development of a three-part spacecraft, NASA developed a system containing a command module and a lunar module. As planned, one astronaut would remain in the command module and orbit the moon while the other two astronauts remained in the lunar module and eventually touched down onto the lunar surface to collect rocks and explore. NASA's first two attempts, launching in 1968, Apollo 8 and 10, didn't land a man on the moon, but sparked the beginnings of lunar orbit.
Minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
It wasn't until July 20th, 1969, when Apollo 11 successfully landed Neil Armstrong and Edwin Buzz Aldrin on the moon's surface.
Thanks a lot. Yeah, I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
With a camera on the lunar module providing live feed from the moon's surface, Armstrong and Aldrin began their famous walk. As the nation watched Neil Armstrong and Buzz Aldrin set up the American flag, one of the most famous quotes was spoken. "One small step for man, one giant leap for mankind," resonated through radios across America and stirred the nation's confidence. Once excitement wore off, the astronauts began their testing. Feeling weightless, they began collecting rocks and core samples to test once they returned to Earth. To begin their experiments, the astronauts explored solar wind composition. Using an aluminum foil sheet, measurements of particle entrapment were recorded to determine the composition of noble gases. This data helped link up holes in the atmosphere's history. The experiment took place on the moon's surface, but results were examined on Earth. The astronauts also monitored the moon's seismic activity through a seismometer. This experiment measured ground tremors to understand the density of the moon. As the hours continued, more and more experiments were finished. The laser-ranging retroreflector was left on the moon's surface to reflect beams toward the Earth's surface. These beams allowed for precise measurement of the Earth-Moon distance. Through all the tests, new information about the moon and its relationship to Earth were discovered.
I was strolling on the moon one day in the merry, merry month of December. Now, May's the month. May, that's right. May is the year of the month. When, much to my surprise, a pair of bunny eyes. That's the truth.
The moon has always remained mysterious and full of secrets, even after space exploration. Scientists today still debate its origin. Some believe the moon formed as the Earth formed, developing from the same cloud of debris, while others believe the moon came too close to Earth and its gravitational pull captured it. Even though Earth rocks and moon rocks are very similar, there isn't enough evidence to fully prove it's the same matter. But even with concrete scientific evidence, skeptics still believe the mission to the moon was a hoax. With ample footage and over 800 pounds of moon rocks, people still try to devour NASA's accomplishment, calling the Apollo mission a staged project. Accusing NASA of fooling not only the U.S., but other enemy countries, skeptics have gone as far as to destroy the integrity of the Apollo 11 astronauts. NASA has been quick to smolder any theories against the moon mission, responding with clear evidence of man's exploration on the moon. Since the Cold War, the shuttle system has influenced some of the best launches. With a total of 6 orbiters, including Challenger, Enterprise, Columbia, Discovery, Atlantis, and Endeavour, the shuttle system has surpassed all expectations. Most orbiters in the fleet have a set of engines that can thrust over 1 million pounds upwards. These are the shuttle's main engines that contain a mix of liquid oxygen and liquid hydrogen. Using propellants from an external tank, the shuttle is able to launch and then discard extra weight. All of the external tanks act as a booster with a thrust of over 6 million pounds. While in the air, the shuttle can operate on internal engines located at the nose and tail. Shuttles have revolutionized space exploration, and Shuttle Discovery is one great example of advancement. Discovery was named after a ship used by a British explorer who helped discover the Hawaiian Islands. As the third major orbiter to function out of Kennedy Space Center, it reaches a speed of almost 20,000 miles per hour. The shuttle has 3 main engines that use a hydrogen and liquid propellant, and 2 rocket boosters that can be reused. Its wingspan of 78 feet dwarfs a small plane. With a crew of 6, shuttle STS-41D launched with much anticipation. Carrying 3 satellites and a new camera system, Discovery had a huge job on its hands. During its first orbit, 2 communication satellites were launched. As Shuttle Discovery continued with its success, NASA continued with the launches. With at least 6 satellites being launched in 1985, Discovery was on a roll and kept the flow of space exploration on the right track. On April 24, 1990, Discovery STS-31 completed a mission that changed how the world fantasized about space.